Hey everyone, and welcome. Today, we're going to jump right into something that powers so much of the AI we see everywhere, supervised learning. We're going to break down how you can teach a computer to make predictions using the data you probably already have. Let's get into it.
So picture this. You've got all these tables, right? Maybe in a database somewhere. They're just packed with historical data. Rows and columns of customer info, sales records, sensor logs, you name it. It's all just sitting there. So the big question is, how do we take this mountain of stuff that's already happened and turn it into a crystal ball that can predict what's going to happen?
Okay, so to turn that data into predictions, we need to build a very specific kind of tool. In the world of machine learning, we call this a model. Now, that word gets thrown around a lot, so let's get a really simple, clear idea of what we're actually talking about.
Right, we hear this term all the time, but what is a model at its most basic level? What is this thing that actually does the predicting?
At its core, a model is really just a function. That's it. Think of it like a little machine. You put some stuff in one side, your input data, the things you already know, and it does some math, it does a mapping, and out comes the other side, your prediction. It's the bridge that connects what you know to what you want to know.
And you know what? We can boil this whole idea down to a super simple equation. Y equals f of x. Here, x is your input. And if you're thinking in database terms, x can be an entire row of data. You know, the year a car was made, its mileage, its engine size. Y is the prediction we're after, like that car's selling price. And that f in the middle, that's the model. It's the magic function that has learned the relationship between all those car features and its final price.
All right, so a model is a function that maps inputs to outputs. Got it. But that brings up the real question, right? How does it actually learn to do that mapping in the first place?
Exactly. I mean, it can't just be some random function, or its predictions would be totally useless. It has to somehow learn the specific patterns in your data. So how does it go from being a blank slate to a smart prediction machine?
Well, this is where the supervised part of supervised learning comes in. It all starts with step 1, labeled data. You basically hand the model a big study guide, a training set of historical data where you already know the right answers. It's a bunch of examples with an answer key. Then in step 2, a learning algorithm starts working. It takes an example, makes a guess, and then checks its answer against the real one. The whole goal, which is step 3, is to minimize the error or the mismatch. The algorithm just keeps tweaking the model's internal math again and again, trying to get its predictions closer and closer to the actual truth. And finally, if all goes well, we get to step 4, generalize. The hope is that the model hasn't just memorized the answers, but that it has learned the underlying pattern well enough to make good predictions on totally new data it has never, ever seen before.
Okay, so let's say we've done all that. We went through the whole training process, and now we have our model. So, now what? What can we actually do with it? Well, it turns out that supervised learning models are really good at solving two main types of problems.
The first big category of problems is all about predicting numbers. But not just any numbers. We're talking about numbers that can exist anywhere on a scale, on a continuous range. In machine learning lingo, this is called a regression problem.
Think of it this way. A regression model answers the question, how much or how many? It's trying to predict a very specific point on a spectrum. For instance, what's the exact price this house is going to sell for? Or what will the temperature be, down to the decimal point, tomorrow afternoon? The answer isn't a simple yes or no, it's a precise numerical value.
Now, the second main type of problem isn't about predicting a number at all. Instead, it's about sorting things into different groups or buckets. We're trying to predict which predefined categories something belongs to, and this is what we call a classification problem.
So, a classification model answers the question, what kind or which one? It looks at some new data and assigns it to a specific group from a list of options. For example, is this email spam or not spam? Is this image a picture of a cat or a dog? Or what genre of music is this song? Is it jazz, rock, or pop? The output is always a distinct label from a limited list. Okay, let's just put these two side by side for a second, because this is probably one of the most important distinctions in supervised learning. On one hand, you have regression, which predicts a continuous value, a number on a spectrum. Think, how much? On the other hand, you have classification, which predicts a discrete category, an item from a list. Think, what kind? Figuring out which of these two you're trying to do is pretty much the first step in any project. So, we've talked about what a model is, how it learns, and the two main types of problems it can solve. Let's just take a moment to pull this all together and recap the most important takeaways from all of this.
So here's what it all boils down to. Remember, a model is just a function at its heart, y equals f of x. These models learn by studying tons of historical examples that are already labeled with the right answers. They learn to do one of two things: predict continuous numbers, which we call regression, or predict discrete categories, which we call classification. And that, in a nutshell, is the power of supervised learning. It's a method for turning all that historical data in your tables into a real tool that can help predict the future.
But, this whole process brings up a really important final question. We've built our model, we've trained it, and it's spitting out predictions. But how do we know if it's actually any good? How can we tell if it's making accurate, reliable predictions or if it's just, guessing? We'll have to dig into that next time.
And that's a wrap on this explainer. Hey, if you found this helpful, do me a favor and hit that like button, share it with a friend, and definitely subscribe so you don't miss our next deep dive. Thanks for watching, and I'll see you in the next one.